Hi, my name is Barbara, and welcome to my brief overview of my Grassfire algorithm. I am going to be taking you through my design choices and my thought processes in creating this algorithm. So first off, I use the Java programming language, which just looking at the screen is probably pretty evident. The initial values for the goal node, the start node, and the size of the graph is just simple input here, nothing more to really go over, which just simply calls an initiate, which fills the two-dimensional array that'll represent our grid problem, and the printing function is also just very basic, having if and else statements for the different values that represent different objects in the graph. Now, what is the most important, though, of this is the actual algorithm in solving the problem. So we'll go down to my solve graph function, which starts off using a while loop, which will continue to execute as long as the destination has not been found and the paths have not been exhausted. It's found there. The first thing that I do is I call my find indices function, which I'll go over here briefly soon. And this pretty much just finds every set of indexes, row and column, in my grid that has a certain value, which will help me with the whole Grassfire spread in the future here. I then take those indices and I call another function that I've made, which is check adjacent nodes. This function will return a value which will help us determine what our next steps are. I'll go over that function in a little bit here, but it pretty much just checks if it's a goal node or modifies the adjacent nodes there as well. So next it checks if the adjacent result is the result of the destination node, then it will break out of the while loop, else it would just continue on. Also has a clause to take care of instances where no paths exist, where it will also break out. Now that the destination node has been found, we need to find the shortest path from that to the goal node. And so that's what happens with this if found clause here, which starts at the destination node we left off in the upper while loop. This area here also has another while loop, which will execute until the goal distance is no longer greater than 0, meaning we have found the goal. It calls yet another function, trace path, which just finds the next node that has one less goal distance than the other node that it's adjacent to. So as briefly mentioned, this one here just simply uses a for loop to find all the indexes of a certain value. And then down here we have the check adjacent, which uses this math here, which is pretty much increments. So one up on the row, one below on the row, one left column, and then one right of the column, checking if it's inbounds first, then checking if it's the goal, and then checking if the distance is less or greater than that of the distance plus 1 and changes it accordingly. Then trace path uses much of the same logic and just checks for the next one it finds of the certain value and just keeps calling it. Now I'm just going to quickly show you an example here. We'll just go with simple 8 by 8 grid, make 20% obstacle, just do column 2, row 5, column 8, scroll up here. So the starting graph is here. You can see it's all empty with our goal and our start nodes. Then this is after the Grassfire algorithm is done, all the numbers that it's reached. And then the shortest path found using backtracking, just following the number signs there.